Welcome back to CAD Level 2, Assemblies and Design for Manufacturing. In the previous module, we introduced this workshop and what we needed to get started. Now, let's quickly review what we did in the CAD Level 1 workshop and set the stage for some new topics, including making multi-part assemblies and considerations for manufacturing. You'll recall last time that we used an application called Onshape to conduct the CAD Level 1 workshop. Now, I'll echo what I said before. I choose Onshape because of its low barrier to entry. It's a cloud-based tool that's free to students and doesn't require a high-performance computer to operate. Simply sign on and go. And, most importantly, it's a collaborative tool, which is something that I strongly recommend you take advantage of, especially in your project-based engineering courses. Remember, we'll be focusing on how to CAD today, rather than how to use Onshape. It's important that we stay flexible with respect to which CAD program we're using, and not pigeonhole ourselves into a single CAD program. Next, our two-step recipe, the basis for using CAD. You'll recall that our recipe starts with a two-dimensional sketch, which is then extruded into 3 dimensions. This process is repeated with an array of tools to eventually build a set of features that creates our part. Today, we'll be building off of those tools that we learned last time. Tools that will allow us to use unique geometry and create a model that is manufacturable. To drive that point home, let's do a quick status check. In the previous workshop, we built some of these shapes using the following tools. In the 3D context, we used Sketch, Extrude, and Revolve. In sketch mode, we used rectangle, circle, dimension, equals and symmetric constraints, and the mirror patterning tool. Finally, we finished by exploring the sharing feature, something you should use often, and the export tool for generating files to be used with manufacturing equipment. This last feature will be particularly useful with respect to the content we cover in this workshop, focusing on manufacturability. Finally, the takeaways from last time. We learned the importance of modeling about the origin and symmetry, since it helped simplify and expedite our design process and made us tolerant of design iteration. We also made sure to fully constrain our sketches with constraints and dimensions so that our sketches were fully defined. We don't want to leave any room for variability. Now, let's run with it. In addition to introducing some new part tools, we'll introduce you to the concept of combining multiple parts together into assemblies. While we're at it, we'll talk about generating part drawings that are used to document and share parts in a standardized way, specifically in the context of manufacturing. Along the way, we'll focus heavily on accounting for tolerancing. To help describe what I mean by manufacturability, let's consider a set of mating plugs and sockets, fabricated on a 3D printer. When the yellow post, A, was modeled, the designer did not account for any tolerance between the post and the socket. They are the same diameter. When they are printed on the 3D printer, even if the printer is the most modern, precise printer available to consumers, unavoidable perturbations in the print process cause the pair to not fit together. In the red and blue posts B and C, we work towards a more reasonable fit. For a 3D printer, tolerances over 1 mm typically provide a loose fit, where 0.5 to 0.8 mm of tolerance provide a snug or even snap fit. There are lots of ways to approach this problem. Perhaps you create a more complicated feature which harpoons the pieces together, making for a permanent yet loose mate. Whatever the solution, just note that the tolerances needed to mate multiple parts together depends heavily on the manufacturing process. For instance, using a 3D printer, while fast and accessible in some cases, is far less precise than using a CNC mill. And with that, our foundation is laid for progressing to our hands-on activity. In this module, we quickly reviewed the tools and concepts used in the CAD 1 workshop, and then established an appreciation for the necessity to account for tolerancing when modeling multi-part assemblies to be manufacturable. In the next module, we'll start modeling and work towards making this multi-part assembly.